Without taking any more time, we would like to invite the sir to take over. Over to you, sir.
Thank you, Tuning Club respective members. Thank you everyone for inviting me in today's session. So we will be covering cloud computing, like what is the buzzwords we are which is driven today in industry, and some of the case studies which will clearly help you to understand clearly how the cloud computing is helping industry and cost of operation of their all the web applications, digital transformation, everything. So my background is already being shared by during the club members. So in the digital master program of TCS, individual has to means go different levels of learning, self-learning. So one is theoretical, then the second one is practical.
Recording in progress.
So first one is theoretical, and second one is practical. So it's the practical is totally based on HackerRank. So people who have worked on HackerRank or trying to get some job in IT company, they must be very aware of the HackerRank platform. So with that, you can learn and code your different languages like Java, Python, Node.js, all this. So this is just background of this digital master program. So in TCS, among like 5 lakh, I think 10,000 or 5,000 associates have got this particular batch, digital master batch. So let's start with cloud computing. So in cloud computing, two words are there, cloud and computing. So cloud in computer terminology means network. So whenever you see in any book or any image on internet, cloud, it simply means something they're trying to represent or host or publish is on in network. So a computer network that is interconnected, you all know, is internet. So something we want to deploy, run, access over internet is nothing but cloud. So in nutshell, we say cloud computing is nothing but computing of resources, maybe image, maybe web application, maybe data over the internet. So this is what in nutshell cloud computing is. It's a virtualization based technology that allows you to configure, create, and customize your application over internet. You can perform development work, you can save your data, you can run your database, you can run your application. Anything which you earlier supposed to do on your single computer machine is now been transformed into cloud-based platforms. So if you have seen, you might be accessing Office 365 emails like Hotmail, okay, OneDrive, Google Drive, Office 365, OneDrive, in which you can create on the fly presentation, Word document, access emails, all these things you can do. So this is one example. So data can be anything like files, images, document, audio, video, and more. So this is just an example of cloud computing. So you see a network of computers interconnected together. You can access emails, you can run the videos, you can do transactions like online banking. You can chat with your peers. You can purchase something online. So all is being run on cloud platform, leading cloud platforms. So let's recap. Cloud computing is nothing but computing of the resources or network, and all the facilities which you are supposed to do earlier on your individual system is now being transferred to networks of computer, which is nothing but cloud. So why cloud computing? Uh, so earlier, if you have purchased the computer, what you used to do, you install some softwares. Before installing software, you install some operating system. Then once you install the operating system, you then install some utility softwares like media player, your file cleaner utilities. So operation and maintenance of your own purchased computer is totally tightly dependent on how do you operate your own computer. Okay, so it's if you are suppose you are the only person who knows the maintenance and you are gone away, then your system will be at exposed to external risk and will not be able to run as per the latest software patch or update. Now, moving this scenario to IT companies. So, IT companies has huge data centers. Like you have eBay, you have Amazon, you have Microsoft, where people's email, people's images, all the data of the individual is stored. So we need a huge number of main force to support and maintain those servers. We need a server room. We need some huge power bank. We need some cooling storage and method to manage those servers. So a lot of manpower is needed. And what if I forget to update as per the schedule of patching the respective servers? It will be totally a security risk for the entire organization, and it will be maybe a huge IT infrastructure risk and issue. So eventually, you need to spend a lot of time and a lot of money. And also, one more important thing you might have realized with this example. Suppose you have purchased a computer having 500 GB of space, but eventually in 24/7 world, you are not using that memory and the hard disk space which you have purchased. So by most of the time, the resources are idle and it is not being utilized fully, and it needs on-demand computing is the need of the future. So how much time I need the resources like RAM, CPU, server, any infrastructure on which I need to run some softwares or I need to run some applications. On-demand computing is the need of the hour. So I may go to some third-party vendor, ask them some of the on-demanding services or some resources. Like give me 500 GB space in order to run my application for 3 hours. They will give to me, and I happily run those services, and it will automatically take care of shutting down the application and then deregistering the application. So this is one scenario where we can see cloud computing and on-demand computing is very beneficial, and it is the demand of or need of the hour. So if you have gone to in your industrial visit to any IT company, the IT admin department, you could have seen a lot of servers, networking, firewalls, routers, modems, switches, all these configuration items, and a lot of service staff, IT service staff, where they are installing some softwares, resolving some access issues. All this being taken care by IT service staff. So this is one scenario where cloud computing is helping the industry to cope up with computing demand, on-the-fly computing demand. So, couple of examples which I have just illustrated, we can conclude that few are the major benefits we get by using cloud computing. Data security. So how do you say that cloud computing is helping me to improve the data security of my industry or my computer? Very simple example, very simplest example we can take. You have installed Java on your respective machine. Okay. Now, if you have seen in last 3 months back, there was a major vulnerability which stormed the IT world, which is Log4j. There was some basic version of the Log4j which was easily penetrated. I think 1.4x or 1.3x version of Log4j. It was very easily penetrated by attackers and hackers. And what they did is just to using this logger object, they just printed important information of databases like database character, username, password, URL, and they just pulled out important data or they just altered the important data just to get the financial age. So if we do not have proper security mechanism around us where important softwares are means updated and upgraded time to time, we may face some sort of these sort of issues and concerns, which are very huge loss for any organization. So this is one example of how cloud computing is helping data security. Improved collaboration. Collaboration means how two different teams work together. So suppose you have a deployment team which takes care of deploying your application onto respective servers. Okay, and you have some developers who are creating the code and checking it into the repository. So cloud computing helps to collaborate between these different teams. Like they will share the same guidelines, same structure of running the code and deploying the application. 24/7 accessibility anytime, anywhere from any part of the world, you can access the cloud platform and your application. Low maintenance cost, you will pay only for the time you need the services. Say, for example, after the examination is over, I need to deploy an examination software which evaluates the all the marks of the student and just display the results. So only for 15 days or 10 days or 1 month, I will just purchase some online space which where I will just deploy the application which will eventually display the examination results. Mobility means I can move from one cloud provider to another cloud provider. Services in the pay per use model means whatever you use, you will pay for the that service. Storage capacity is unlimited. Is just opposite to very limited storage services in when we purchase individual softwares or individual data centers. Data security, I already explained to you. So these are the major advantages of cloud computing. So if you have visited any IT department in any IT company, maybe in Indore or any other location, go to the IT admin room or IT service desk room. You will see almost 2-3 years back, they used to sit with a lot of computing resources like switches, modems, routers, laptops, and now it is being shifted to cloud platforms which are managed by cloud platform, all the services, their computer network, their storage, all these things. So if we want to design any cloud services or any cloud computing based application, it will be having different layers as per the architecture of cloud computing. Client infrastructure like what are the networks, what are the servers they are using, what images for the HTML file they are using, and they are exposed to internet and they access some backend services like some RESTful web services or databases. And This is all being taken care by cloud service provider. We need to just build the backend application, backend services, for example, RESTful web services which are accessing your database. So VM virtualization machine, you might have heard. So suppose I have installed I have purchased a laptop or desktop machine, and I want to just install another operating system. So there are two choices I have. I can just partition or divide that hard disk and do dual booting. There's two operating system I have, and if I want one operating system but multiple guest operating system on the top of this, then there is a concept called virtualization. So this is the virtualization concept. We have one host operating system. Suppose on my laptop I have installed Windows, and then I have installed in VMware software, and then using that software I can create virtualization machine on top of that host OS. Like suppose I have 500 GB hard disk and 16 GB RAM, then I can divide this into say 300, 200 each. Three virtual machines I can create using some portion of the RAM and some portion of the hard disk. So we can say virtualization is the process of creating virtual environment to run different applications and operating systems on same machine or on same server. It can be anything like system, storage device, network application servers, and anything. So it depends on the business case for what purpose you are creating the virtual machine. Now, why the need of virtual machine arose when we designed and developed cloud computing infrastructures. So suppose we have different applications. Suppose your application in simple Notepad or your Chrome browser or Mozilla browser. Then we have operating system, and then physical hardware like your processor, networks, keyboards, graphics, storage, all these things. So if we do not have any virtual machine, then a single operating system owns all the hardware resources. Okay. So all the hardware is being interacted with operating system, and it is being taken care by the OS. Now with VM, you share your physical hardware among the small virtualization machine VM. So on each VM you allocate some portion of RAM, some portion of hard disk, and that is called the guest operating system. So you can run different applications, different softwares on these virtual machines. Sorry. So this is the basic underlying mechanism of cloud computing infrastructure. Another architecture which is used by cloud computing is service-oriented architecture. If you remember, like 5 or 10 years back, service-oriented architecture was very popular. How it works, like you design the web service, that means a program which runs on different machines. It's a platform neutral model. Means I can write program in Java and I can communicate it with a program written in .NET. So the contract which helps us to achieve this platform neutral thing in service-oriented architecture is WSDL. I can give a WSDL to a Java client or a .NET client. They will just generate the stubs and then call the methods. So this is the service-oriented architecture. So it was the major buzzword almost like 10-15 years back. Now it is being replaced by lightweight RESTful representation state transfer architecture. So SOA, it is the almost web service 10-15 years back used to be created using this particular architecture, and we used to create the service provider and service consumer. Service consumers are simple stubs which will call the methods which are published as a part of WSDL contract. So this is service-oriented architecture, and it was also part of cloud computing, and we can work in cloud computing with or without it. It is used mostly almost like 10-15 years back, but nowadays if we have legacy application, we are still using it, but we mostly try to convert it into RESTful web services. So before service-oriented architecture, everything was monolithic. Monolithic means something, suppose you are creating a simple web application, and if a web application has 5 modules, 5 services, then all these 5 services will be hosted on will be hosted on one place, and in the entire application, in the entire application, it will be having say 5 services, and eventually this one big box having 5 services. So this is before SOA, but after SOA, when it was introduced, we have more collaborative, interoperable, integrated services, like different services being segregated into different modules and different boxes or servers, and they can communicate with each other with ESB, integrated, I think enterprise bus, right? The enterprise bus is the mostly point of choice almost like 5-10 years back in order to communicate between service-oriented architecture web services. So you can see different reusable services which we have developed as a RESTful web, SOAP-based web services that are being accessed with different data repositories. So these services are just accessing different data repositories, like, or databases, we can say. Another important part of cloud computing architecture is grid computing. So it's a distributed computing in which a processor architecture that combines various different computing resources from multiple locations to achieve a common goal. So if you have into the gaming world, so we used to use this particular model or this particular architecture in which we play the games across different host machines, but they are connected with a central server. So they usually perform a computer cluster. These clusters or laptops can be of different sizes and can run on any operating system. Another example is ATMs. So when we say in ATMs, grid computing is mostly the architecture behind it. Another part of cloud computing architecture is utility computing. It is one of the trending IT service model which provides on-demand computing resources like storage, computation, programming services. So, example of utility computing on internet, you see nowadays you do not need to install Eclipse or any other third-party software to complete your running the program which is written in Java or .NET or any other application. Also, you can run JavaScript program on the fly. Also, you can edit the Excel sheets on the fly. So there are some utilities which are available as a part of cloud computing solutions to you. Another, I think you might have used if you want to convert your images to PDF. So such utility computing services are available on to you free of cost or maybe on limited basis. So it definitely minimizes the operational cost and increases the efficiency of resources. It reduces the IT cost, greater flexibility it provides, and very easy to manage. So we have organizations like Google, Amazon who establish their own utility services for computing, storage, and applications. Now, analogy we already made. Cloud means network of computers. So a network of computer which if you have purchased only for your own use, which is specific to your need, and you do not want to, and you want to make sure that no one else can access it apart from only limited person to whom you have given the access, then it's called private cloud. And if you have, if you want, everyone can access your, everyone can access your cloud platform, then it is called public cloud. So, for example, OneDrive given by Microsoft, Google Drive given by Google, and many other cloud providers who are offering you public cloud services to store and maintain your files. So, public cloud provides shared a platform which is accessible to the general public through an internet connection. It is operated by pay-as-per-use model. So also public use of public cloud is limited. So say after 25 GB is over, free storage is over, Google asks you to buy some more space by paying some money. Same happens with Microsoft OneDrive. Another example we can say, we can create elastic computing EC2 platform, which is nothing but some servers you buy on the fly from Amazon and use it for deployment or storage of your files, images, or any other resources. Now, private cloud, as I said, it's more specific to your organization. Say, for example, you buy some specific OneDrive, which can only be utilized by your company mates or your organization. Another example I can give, supposing TCS or any organization or NMAS, your data regarding your admissions, your results, they may use some online cloud provider to give some space, and then they can just use their space only for internal purpose. They will not allow any third party or other individuals which are outside of their organization to use and access this data. So this is one example of private cloud. SP data center, Microsoft, open to us some of example of private cloud. So we can have any example which any organization use for storing the data for their own purpose can be tagged to private cloud as an example. So this is one pictorial representation where different organizations are accessing their data or resources which are available on public cloud, or maybe on some part of the data is being only exposed to organizations employees, so that are part of the private cloud. Like you want some data to be available to everyone and some data only available to specific users. So we can have mix of private cloud and public cloud. So in finance, healthcare, and universities, it is mostly the model which is usually followed or adopted. Another model of cloud is community cloud. It is a cloud infrastructure that allows system and services to be accessible by only by group of several organizations to share the information. So, for example, if you have seen COVID, so during COVID, that OTP mechanism were there to just access whether someone is vaccinated or not vaccinated. And this particular portal, which they have developed, is example of community cloud, where the cloud infrastructure allows systems and services, and it is accessible by a group of several organizations. So not only India, they have just migrated or reshaped this portal to different countries. So we can say it's a community cloud example. Now these are the different cloud platform. We have seen type of cloud. We can have private, public, hybrid, and community. Now see what are the different cloud service models. So you have purchased the cloud service provider, but what kind of services they will offer to you? So they will offer three types of services: infrastructure as a service. Infrastructure means something which is already built, and you just go there and then just utilize their infrastructure. So, for example, you enroll to NIMS. What is the name? NIMS. Yeah, this college, NMIS. Okay. Now you go to this particular college and then just utilize their infrastructure like teachers, their computers, and their library, their sports ground, all this. And after 4 years, you just sign off. So, and you have to pay for using this particular infrastructure services. So we can say it's a pay as per user model, pay as per use model. So you use the infrastructure of respective cloud service provider, and once you are done with your usage, you just sign off. Then platform as a service. Platform means if we say pizza service. So pizza service provider is a platform where you go to the pizza service provider, you use the chairs, you use the resources there, and then just consume the pizza and come back. Software as a service, also it's an on-demand software. Is a software distribution model in which services are hosted by a cloud service provider. You use the services and just use it and then close it. You do not need to manage the life cycle. For example, you open the Gmail, you access the emails, and then send the email, receive the emails, and then just close the email. So that is one example of software as a service. Just to add you one more example, pizza as a service. So whenever you go to any pizza shop, you have a dining table, you have some electric gas stove, then on top of it you place some oven, then you have pizza dough, tomato ketchup, toppings, cheese. So when you do all these things in your home, then we say it's traditional on premises. Let's see example of infrastructure as service. Okay. So they give you dining table, they give you soda, they give you electric gas, they give you oven, fire. Okay. They give you pizza dough, they give you tomato sauce, they give you toppings, they give you cheese. So the infrastructure is being given. You go to the pizza shop and then just use their infrastructure. You go there, then bake them, and then eat it, or maybe take away from the pizza shop and then come back. So you are using their infrastructure for creating the pizza and consuming it back at home. Platform. So you use their pizza delivery platform to get the pizza. You just get the pizza by their platform. By using their platform, you use their app to order the pizza and it's get delivered to you. So it's a dine out. The third one is the dine out. You go there, order the pizza, use the service, and come out. You do not need to care what is being exactly happened behind the scene. So software as a service, you just consume the service. Platform as a service, you use their platform. For example, another example in terms of software, if we go, so suppose you are a user of Google, so you go to Google App Engine, use their platform to develop the app, and then just create the app and then just deploy it. So you have used their platform to create the application. So these are the different, we can say, cloud service models: platform as a service, infrastructure as a service, and software as a service. Software as a service means totally just consuming the application or service. Platform as a service means you are using their platform to build the application or creating the application. Infrastructure as a service means you are relying on their infrastructure. You use their infrastructure for some time and then create whatever you want to create, and then just pay the money, and then go away. In the software world, we can say software as a service. Zoom meeting, which presently we are using, we do not need to take care of what exactly Zoom is doing to host our meeting, how they are hosting, what technology architecture they are using. Gmail, which they are using. Another example of platform as a service is Google App Engine, which I have already told you. Another is OpenShift Container Platform. It's a DevOps tool just to host the microservices. It is developed by Red Hat. And infrastructure as service, infrastructure is AWS that focuses on providing infrastructure services, like you can purchase and host your application on EC2, different servers you can purchase. You can run Lambda functions before a certain events are triggered or after the certain events are triggered, like this. So this is the examples of different cloud service models and their real practical examples. So whenever you open Gmail, it's clearly example of software service. Whenever you want to create an application on Google App Engine or any other third-party platform, Google, AWS, or Microsoft, then it's a platform as a service. And third one is infrastructure as a service. Complete suite of infrastructure you are purchasing on the demand from different cloud providers like AWS, Google, or Azure, Microsoft. So you can see infrastructure service example, platform and service example, software as a service example, Google Docs, Gmail, Microsoft OpenOffice. There are some advanced concepts also, which I think in the previous slides, like data security, which I have explained to you, and the operations, I'm just recovering them. So security is very important aspect. As I told you, one example of Log4j, in which if we do not update the softwares properly, our computer will be at risk, our infrastructure, our application will be at risk. So data in the cloud should be stored in encrypted form, no one can access apart from the one who has stored and placed this, or the author of the particular data. Some of the examples of cloud computing applications, it has impact in all the fields like business, entertainment, data storage, entertainment, education, GPS systems. So we can say in business application, we can see Chatter, data storage. You must see Forshare.com, management applications. We can see different Office 365 apps, social applications, Facebook, Twitter. So all these are examples of cloud computing applications. So we already covered like availability, scalability, performance, portability, interoperability. Means interoperability means suppose you have created an application on server X, it should be easily configurable and runnable on server Y. Okay. So reliability means whenever I am trying to access the data, no one else can trap it and just evade my security. Availability means 24/7 your data should be available. Computing performance means, for example, you are booking a ticket on IRCTC or booking a travel ticket on Redbus or any other web application or mobile application. It should be fast, quick, and easy. So if we host our data on mobile, if we are running some application on our mobile and the mobile is connected to network of computers which are nothing but cloud, so we can say it's nothing but cloud computing. So cloud computing, which offers such Microsoft that smartphones that have rich internet media support require less processing and consume less power. Processing is done in cloud, data is stored in cloud, and the mobile devices serve as media for display. So we have different platforms which support third-party applications that are deployed in cloud. So for which operating system which are cloud computing based, we can say it's Google's Android, Apple's iOS, then BlackBerry, Symbian, and Windows mobile phone. So when we talk about mobile computing ecosystem, we can have public-private cloud infrastructure, local and private cloud providers, content and service providers like Netflix, American Online Service, CNN, Dropbox, all this. Now we have different cloud service providers in the market, but presently in the market we have AWS, which is well known because of ease of operation and its computing capacity. Computing capacity means how much data you can compute out of the infrastructure which you are using of respective cloud service provider. So suppose on demand, currently I'm using 500 GB in order to do certain operations on my application, and suppose demand increases from 500 GB to 5000 GB, so you can easily scale up and scale down using AWS infrastructure. So it is more easy, though it has lots of bugs and issues, but it's very easy and easy to operate, easy to understand as compared to the other cloud service providers. So this is the matrix we have, that what are the different OS we can use, what are the virtualization we can use, how you can access the AWS. So AWS we can use command line or front end, both, using portal also, or web-based administration in Google application. So in this half an hour or 40 minutes, I think, yeah, almost like 1 hour. So We have covered what is cloud architecture, what do you mean by cloud, what are the challenges which we face like data security, administration, availability, all this. And then we also covered the different service models like platform as service, infrastructure as service, and software as a service. Now, see how we can apply this, and there are some very good examples. We can say case study, which you have experienced, you yourself have experienced, uh, and you are happy customers because of cloud computing. So, as I already told you, we have AWS, Microsoft Azure, and Google App, this Google Cloud Computing Platform, and they offer different set of services, infrastructure services or enterprise level services. And you can see Office 365 is being hosted by Azure. We have Microsoft Project Online. We have different Microsoft projects are now being hosted over Azure. And another cloud provider we have is Amazon Web Service. So many services. Amazon EC2 just to purchase the server and deploy your applications on Elastic Computing Cloud. Amazon RDS, which is the database service. Elastic Block Storage, which is used to put your operating system on respective hard disks. Amazon S3 just to store the objects, files, images, HTML, JavaScript, anything in terms of files onto S3 buckets and so on. This is very less used in the industry because of the complexity. So, as I told you, you are the experienced person who have been using the cloud computing, but without knowing that how the different service providers have migrated to cloud infrastructure, and they are happily serving millions of users. So remember the pain days, almost like 5 years back, or maybe 3 or 4 years back, I think. When you sit on the computer, you have to go to your relative during summer or during emergency time, or maybe you are means moving from your job location to your home location. It was very painful days where you sit on the computer or you ask your friend who is sitting in US who has good internet connection that please book my ticket. I have to go to my home for some purpose which are of maybe immediate or emergency need. So hardly out of 10 attempts, you succeed in one or two. It was very painful and frustrating time for IRCTC users. So they use the cloud service, different models, and they migrated to cloud. So now it's very easy to book the ticket even during the very peak hours. So you can see this problem statement. So some of the problems can be of yours also when you have used IRCTC website. So the call ticket timing 10 a.m. to 12 p.m. Whenever you see the traffic during this time period, you see it's 10 times higher than the rest of the day. So when we see the trend on mobile also, we see that 49 transactions are getting the hit, and it's more than 42,000 Google hits take place on an average during the Tatkal booking hours. And if you see the mechanism used by IRCTC, like the locking mechanism, it says like one seat cannot be allotted for other individual, but Google can share same information to different people. Then how IRCTC will manage such huge user base and transaction? So we can say that they can allow agent login at the peak time, but it's not good approach and it's not ubiquitous. it is not recommended by all the users. So what we can do, instead of 4 servers, 5 servers, 10 servers, why not add thousands of servers on demand? Whenever the demand of your application or usage of your application for booking the ticket increases, why not increase the servers and just host the same IRCTC app and serve the users? And when the peak time gone away, like 10 a.m. to 12 p.m., just come back to the ordinary infrastructure where we serve the normal user base. So this is only possible because of cloud computing solutions or cloud computing infrastructures, which are nowadays almost used by every organization. So cloud computing is one of the optimal solution to tackle the server load for the IRCTC. So when we see AWS infrastructure and purchase the servers, there is a concept of region and availability zone. So whole earth they have divided into different regions as per the country, and in every country they have different availability zones, and this is how they are divided the whole earth, our whole planet, into different availability zones and regions. And whenever you request something or some piece of data, maybe image or maybe an email or anything, they just detect your location. So nowadays in every application, whenever you open that application, that in the browser or mobile, they ask you for your location, right? So this the reason why they are asking you for your location, because they want to understand their location, and accordingly they want to pull the data from your nearest place and serve you fastly. That's the reason. If you see your mobile or your desktop, most of the application asks you for your location. So if you are sitting from Mumbai, you should be getting the data from your north side server, northern part of the country, and sorry, in Delhi, if you are sitting in Delhi, and in Mumbai, it should be getting the data from the western part, western region. So in this case, you can see cloud computing comes to rescue, and we can have cloud infrastructure placed in southern regions such as Bangalore, Hyderabad, Chennai, and many other major locations. For deploying in cloud, if one region is loaded heavily, we can go to the nearest region server, where this less traffic helps to overcome the unnecessary delay. So now you should have understood very well in these last 2 slides that why your mobile used to hang or when you request for booking the ticket almost like 5 years, 6 years back, because they are not able to access the data or pull the data in the required amount of time because of heavy load on the server. Another case study we can say using Microsoft Azure Payment Gateway. So one example of payment gateway is CyberSource Payment Gateway, in which you give the credit card or debit card or net banking information to payment gateway, and then they simply get your data and then hit the respective banks or financial institution and get the payment done, and then reset the confirmation failure or any status code back to your application. So let's see how payment gateway case study using Azure helped the payment gateway to become more profitable. So as you already know, many enterprises, merchants, suppliers just you access the web application to perform online credit card payments around the world. The deployment setup and architecture of the existing was built using ASP.NET, for example, The legacy systems lack the capability to scale on demand and control system downtime. So as I already told you, if the load increases, we need to increase the servers. And also, if one server get heavily loaded and failed, then we should have automation in place where whenever the server is down, another server with same application should be rebooted, and we should manage the downtime. So this is one for payment gateway. This is another case study. So one of the optimal solution to overcome this payment gateway failure or payment failed is to migrate their system to Azure and use infrastructure as service to reduce the maintenance cost, maximize the performance, and achieve zero downtime and zero data loss. So, as I told you again, they introduced a pair of availability sets, availability nothing but servers, or we can say two VMs. First availability set included a pair of web servers, VMs that acts as load balance system to balance the incoming load between the two cloud VMs. And we have second availability set which consists of another two SQL VMs. So what we are doing exactly, we are just mirroring the database on different virtual machines, okay, in order to meet the demand and in order to increase the fault tolerance in case some of the VMs which are hosting the database are getting down. So this is the architecture. So we can see we have different availability sets which are having which are nothing but virtual machines in the cloud, and then we have other components like which are present in the Microsoft Azure platform. But the major is we are putting the databases onto different views. NASA also uses cloud computing infrastructure and architecture. Let's see what kind of component they are that they are earlier using are now hosted on cloud services platform. So scientific related data they want to store or compute or analyze. So science scale application development, compute intensive processing, very large data they usually compute. Timely sharing of the results with all the stakeholders of their mission critical application. So what they usually earlier was doing 5 or 10 years back, build the system, buy it, and these are the three different solutions they earlier had. Do nothing, buy it, go through the lengthy procurement and provisioning process for basic IT infrastructure services and IT security standards. If you search on internet, this Nebula Cloud, you will see how the mission critical applications are now being hosted on cloud platforms. What are the use cases? Means for what purpose they are using this cloud platform? Processing large data sets, run computer intensive workloads. Suppose you want to run a program, simple Java program, which reverts a string, but that string is of say 50 lakh character. A simple algorithm they want to run, but with different data sets. So they want to understand the behavior of the program or analyze the results. So run intensive workloads on respective computers is one of the use case. Require infrastructure on demand, store some critical data which is mission critical and scientific data. Share information with the public. Suppose they want to just share the experimental data they had done in last 50 years. That would be very huge data. So they just wanted to expose this to public so they can use the cloud platform and their respective storage services to share the information with the public. So another great example is Nebula Cloud, in which scientists directly access to Nebula Cloud. Okay. What are the principle and experience of the users? Like open and public APIs everywhere, open source platform, apps and data, full transparency, open source code and documentation releases, reference platform means cloud model for your federal government. And there are other major experiences which user I can easily launch the VM, shut down the VM after my work is done. I need not to work on creating a desktop specific to a specific scientist and his need. I can simply go to the cloud service provider, purchase the VM, install the softwares which are needed for my scientific and mission critical purpose, and then just shut it down when it is no longer needed. So ease of use, how easy it is to use the services. So scientific application will not drive clouds, but will benefit from their widespread adoption. Means we can adopt them in order to compute very large data set related programs. It's a disruptive technology in many ways, and the university's agencyship will take some time, and hence will likely get significant benefit and will get ahead. So what I have just illustrated to you, like IRCTC case studies, NASA-based case study, and payment gateway-based case studies, which are the major benefits we can say, which are being used by different organizations, and they are happy. They are serving happy customers. So we covered different cloud computing technologies, their deployment service models like service software, service infrastructure, service and platform as service with sample examples. Some of the advanced concepts like grid computing, community computing, different types of data security which we can place. We had learned how IRCT has evolved with cloud computing technologies, how the peak hour booking time, that is the Tatkal ticket booking time, is now very easy to log in and book the ticket using Tatkal ticket booking hours. Also, like when we do the online payments, how they are connected to cloud computing based infrastructure like Azure or AWS, and how you are currently processing the payment. Also in scientific world, like NASA is often using this Nebula Cloud, hosted maybe I think on Azure or AWS, to run their programs which requires intensive computing capacity. So I have just covered the basic things and the case studies. So at least after the end of this our session, you should be at least after going outside of this session, you should be able to on your fingers can count the benefits and just correlate a few of the cloud computing services which you are using already or seeing them like Gmail, Office 365, Microsoft Office 365 app, when you log into hotmail.com, when you are storing the data into Google Drive or OneDrive, Dropbox you are using just to store some of the files. So these are the few case studies or scenarios you can think of. Another example you can take away is IRCTC, Tatkal booking hours, which you can remember because you already have experience of booking the tickets on IRCTC platform. So with this, I just conclude. I invite all the respective audience to have any questions, queries regarding the career. If you want to build, what is the future? What is the trend? which presently industry is going through, what kind of a skill set nowadays it is required, and are there any major benefits in terms of compensation and salary if we see if someone is skilled and well groomed into cloud computing technologies? So over to you, audience. If you have any questions, I will be very happy to answer those.
No queries, sir. Thank you, sir, for such an insightful session, an informative session. I am sure everyone here loved to hear from you and would take away a valuable information. Valuable information that is sure to help them further in their career. We have a feedback link for all the participants to fill. And now I would like to request Ms. Akriti Jain, Vice President of Turing Club, to present the vote of thanks. Thank you, Arya. Good afternoon, sir, and good afternoon to all the participants. So thank you, sir, for such an informative and insightful session. Your depth of knowledge and expertise in the field will surely help us. I would also like to thank our Director Ma'am, Prachi Gharpure, and Associate Dean, STME, Dr. Akil Banglowala, for always supporting us. A huge thank you to our Faculty Coordinator, Dr. Dharmen Sharma, as well, for always guiding us. At last, this workshop would not have been possible without the participants. Thank you so much, everyone. Thank you, sir.
Thank you, Akriti, and thank you, Turing Club, for organizing such a wonderful session and giving me the opportunity. If anyone has any questions now, they can reach me over email, which I think Turing Club has. Anything regarding career or certification they want to do, cloud computing, what kind of skill set they want to groom for the future, what could be the industry trend in next 10 years, what kind of preparation they need to start the career. All these things I can easily answer, or maybe we can have any other future sessions on this. Thank you.
Yes, sir. Thank you, sir. We'll surely contact you. Thank you, sir. Thank you, sir.
Thank you, everyone.
Recording stopped.